All right, we have added rational expressions. Now we're going to subtract rational expressions. The process is going to be very similar. There's just going to be a part where we subtract numerators instead of adding numerators, but we still need a common denominator. Um, we probably won't have one, so we'll make sure we get one with multiplication, all that good stuff. So let's rewrite the problem. As we rewrite the problem, or actually write the problem, they gave us a problem in words. So we'll write this out as a subtraction. It says difference, so let's subtract. But remember, we are going to factor our denominators as we rewrite this. So we have x plus 1 over, are there factors of negative 16 that add up to negative 6? And there are a positive 2 and a negative 8. That adds up to negative 6, multiplies to negative 16 and adds up to negative 8. Minus, because they said to find the difference, x plus 1 over, can we factor factors of 8 that add up to 6? That's just a 2 and a 4. X plus 2, x plus 4. Okay, so now let's take a look at our denominators and see, do they have anything in common already? What else do we need to get them completely in common? We have an x plus 2 here and an x plus 2 here, so that's good. This expression on the left has an x minus 8. Ooh, we don't have an x minus 8 over there, so we are going to multiply in an x minus 8 to the denominator, which means we have to multiply that into the numerator as well. All right, so now both denominators have an x plus 2 and an x minus 8, x plus 2, x minus 8. And I know you guys have already spotted this x plus 4 that the other side needs. So let's multiply in an x plus 4 to the numerator and denominator. And now we have a common denominator. All right, before we can do the subtraction, we've got some prep work to do on these numerators. So I'm just going to do this prep work below. We have x plus 4 times x plus 1. Distribute the x. X times x is x squared. X times 1 is plus x. 4 times x plus 4x. 4 times 1 is plus 4, leaving us with x squared plus 5x when we combine those like terms, plus 4. So I'm just going to cross this off and write it in standard form. We just multiply that out. X squared plus 5x plus 4. Again, the reason why we're doing this is when we do the subtraction, we subtract like terms of the numerators, and we only can identify the like terms when they are multiplied out in that standard form. All right, so let's do the same thing with this other numerator. We have an x plus 1 times x minus 8. So distribute your x, we get x squared. Watch out for your signs. That's an x times a negative 8, so minus 8x. 1 times x is positive 1x, and 1 times negative 8 is a negative 8. Combine your like terms, we have x squared minus 7x minus 8. We can cross off that numerator and replace it with its standard form, x squared minus 7x minus 8. All right, so now we're going to do our subtraction. So we know our common denominator is going to stay the same. That's going to be an x plus 2 times x plus 4 times x minus 8. The numerator, well, the first, oh, I can't even see it anymore. Where'd it go? There we go. So in the numerator, what we have is an x squared plus 5x plus 4 minus the other numerator, which is x squared minus 7x minus 8. Okay, so let's go ahead and do the subtraction of our numerator. We are subtracting like terms. So we have an x squared. Do we have any x squareds that it can subtract with? So x squared minus x squared those cancel each other out. We no longer have an x squared. We have to be very careful with our signs. We have a 5x minus a negative 7x. If I write that up above, what we just said was 5x minus a negative 7x. What happens when you subtract a negative? It turns to addition, so we actually have 12x. Then we have a 4 that will combine with a minus 8, but we're subtracting it. So 4 minus negative 8. 4 minus negative 8 turns into 4 plus 8, so plus 12. Over our denominator, x plus 2, x plus 4, x minus 8. Oh, I forgot my parenthesis on that last one. That probably bothers some of you guys. There we go. Okay, before we try to simplify this, let's stop and get our domain. So the domain, take a look at your denominators. What can x not equal? We don't want a 0 in that denominator. So if you set all those factors equal to 0 and solve, you're going to get a negative 2, a negative 4, and a positive 8. Okay, back to our problem. To try to do any simplifying, we're going to see if we can factor this numerator and hopefully have a common factor with a denominator that we will simplify away by canceling it out. So that numerator we can factor. There's a 12 common factor, so let's factor a 12 out. Leaves us with x plus 1. Our denominator, x plus 2, x plus 4, x minus 8. All right, now that everything's factored, does anything cancel out? We've got a 12 on top. I don't have a factor of 12 on the bottom. We have an x plus 1 on top. Do we have a factor of x plus 1 on the bottom? And we do not. So sometimes nothing simplifies away, and this is our final answer. We are going to add in, that we know that the difference of our two rational expressions is this. For x's that are not equal to negative 2, negative 4, and positive 8.